Bonjour, mes amis. I am Patrick Byers, Commercial Horticulture Field Specialist with the University of Missouri, and I'm so excited to be with you here today to discuss productivity and elderberries. A bit of background about myself. I work for the University of Missouri Extension as a Commercial Horticulture Field Specialist in southwest Missouri. I serve fruit and vegetable farmers in a 9-county area. I'm also a farmer. I own 30 hectares of land near Springfield, Missouri. On my farm previously I grew peaches, and at present I'm transitioning into berries and vegetables. I also am excited to be co-director of the Missouri Elderberry Development Program, a comprehensive program that was initiated in 1997 to develop elderberry as a commercial crop for the farmers of Missouri. Our program has been focused on cultivar development. We also conduct research into cultural practices. We're working on characterizing the elderberry pest complex, and we collaborate with several labs that are investigating the health-related activity of the bioactive compounds found in elderberry. Since our program was initiated in 1997, we have been excited to see the growth of the elderberry industry from 0 hectares in 1997 to over 120 hectares at present in Missouri and surrounding states. Our program is headquartered in Missouri. Missouri is centrally located in the United States. You can see the state shaded in red here. Our average minimum temperature in Missouri is negative 7.2 degrees C in January, and we expect average maximum temperatures of over 30 degrees C in July. Of course, it can get colder and warmer than these average temperatures. Our average annual rainfall is a bit over 1,000 millimeters per year. Our soils are good agricultural soils. A typical soil in Missouri would be a silt loam soil. Our frost-free growing season extends from April 12th to October 30th. There are many factors that can potentially influence productivity in elderberry, and certainly farmers are concerned about the effects of productivity on the sustainability and profitability of elderberry production. For the purposes of our time together today, I'd like to cover these topics. First, we'll take a general look at productivity. Then we'll focus in on some issues that directly influence productivity in elderberry. We'll look at environmental issues. We'll talk about cultivar selection. We'll talk about cultural practices and how they influence productivity. We'll then spend some time talking about pest management and the influences of insects and diseases on productivity. We'll then conclude with a discussion of harvest management and productivity. Before beginning our discussion of productivity, I think it would be useful to define the term. Productivity in a broad sense is maximizing the production of fruit from an elderberry planting that meets appropriate quality standards. Now, productivity is an intersection of 3 factors. The first of these factors is the genetics of the plants. Each elderberry cultivar is a unique package of genetics and will perform differently in different settings. The second factor is the environment. Certainly, environment can bring forth the full potential of the genetics of an elderberry cultivar, and in other cases, the environment can actually reduce the potential productivity of a cultivar. And the third factor is the expertise of the elderberry farmer. For example, the elderberry farmer chooses the genetics, the elderberry farmer chooses the environment, or at the very least can modify the environment to make it suitable for elderberries. The elderberry farmer can also make timely management decisions, which are very important in productivity. And third, the elderberry farmer has the ability to respond to challenges. And you can see, looking at these 3 points of productivity, that if there is an issue with any of the 3 points, it can certainly affect the overall productivity of an elderberry planting. Now, productivity is just one component of profitability, and from a farm standpoint, profitability is oftentimes the overriding concern. We have to remember that not just productivity, but efficiency is just as important in overall profitability. For an example, elderberry harvest in Missouri is a hand operation. It's very expensive, and farmers have developed methods of making hand harvest more efficient, although at the expense to some degree of profitability or productivity. Financial management and successful marketing are just as important too in overall profitability as productivity. The first aspect of productivity that we will consider is cultivar selection. Remember, the cultivar selection is very dependent upon the area in which the elderberries are being produced. And the cultivars that are adapted to central United States, Missouri for example, will not be the same cultivars that are ideally suited for Quebec. But there are some characteristics that we can look at related to cultivar selection to help guide the determination of adapted cultivars. First characteristic, of course, is plant characteristics. Such attributes as berry size, plant size, yield, flowering habit, and ripening season should all be considered when choosing an adapted cultivar. Overall adaptation to the growing environment is important. We'll discuss this further in the presentation. But we know, for example, that elderberries are very responsive to their environment. And in fact, we have seen situations where an adapted cultivar in central Missouri is not as well suited for production in southwest or southeast Missouri, a matter of just 100 miles or so difference in location. Pollination issues. There are evidence in our collections of elderberries that certain elderberry genotypes do set fruit best when a provision is made for cross-pollination. Other elderberry cultivars will set adequate crops when planted in uniform plantings. Yield is an important attribute of a cultivar. The characteristic that's particularly important here, though, is consistent yield from year to year. We have an elderberry cultivar, Wildwood, for example, that can be extremely productive in years where the environmental conditions are favorable, but then it drops production when environmental conditions are not so favorable. Another cultivar in our plantings, Bob Gordon, is very consistent year to year in years when the environment is favorable and in years when the environment is not so favorable. So Bob Gordon is a favored cultivar in Missouri. We're certainly interested in pest resistance, particularly resistance to some of the major issues such as aryaphyte mites. And then, of course, the intended use. Is the elderberry fruit going to be used for health supplements? In that case, the content of bioactive compounds, the spectrum of bioactive compounds is very important. Is the elderberry intended for use in juice, jelly, jam, or wine? If that's the case, then overall productivity may overrule the presence of bioactive compounds. I'd like to share with you an example of how cultivar characteristics can influence productivity and efficiency. In our cultivar trials in Missouri, we have noted that the elderberry plants have one of two flowering and fruiting habits. The first habit that we call determinate, the plants produce a single large flower head. You can see it here in this shot. Each stem has one flower at the top. The flowering is uniform, the harvest is uniform, and in fact we can harvest the majority of berries from a planting of this type in 2 to 3 harvests. Contrast that situation with cultivars that have what we call indeterminate flowering and fruiting habit. As you can see in this picture here, we still have a large central flower head, but there are typically 2 or even 3 offshoots coming from that flower head that produce smaller clusters of flowers that bloom later. In this situation, the harvest season is spread over easily 3 to 4 weeks, requiring at least 1 and sometimes 2 additional harvests to collect the fruit. On the other hand, this type of flowering and fruiting habit does hold potential for the production of flowers as well as fruit from a planting. The smaller side shoots, the flowers could be harvested, and then the large central flower cluster could be allowed to remain to set fruit and berries for harvest. Our next consideration related to productivity is environmental issues. And as we talked about at the beginning of the presentation, the interaction of the genotype, the cultivar, in the environment oftentimes is a key factor in productivity. Now, the first issue related to the environment is the macroclimate versus the microclimate. A macroclimate, of course, is the climate of the region in which the elderberries are being produced. Here in Missouri, for example, we have 3 broad areas that we consider when we talk about macroclimate. We talk about northern Missouri, southwestern Missouri, and southeastern Missouri. And these parts of the state vary widely. And I suspect this would be the case in an area that is as large geographically as Quebec. But we also need to think about microclimate environmental issues. And these are the areas within a farm or within a property where the elderberries are produced that might make a particular area on the farm more suitable for production. For example, an area with better drained soils would be a good site versus an area on the farm that did not have good drainage, or perhaps an area with better air movement would be better than an area that did not have good air movement. So even on a farm scale, it's important to look for areas within the farm that are suitable for elderberry production. Freeze and frost damage. We seldom experience cold injury from midwinter cold on elderberries in Missouri. Again, our temperatures just are not cold enough to damage a crop that is naturally well suited for our environment. At least in theory, it could be a problem, but we have not noted it to date. But we do see some issues related to frost damage, and this is damage that occurs from cold temperatures primarily in March and April in Missouri. Our elderberries break bud early in the spring, and frequently by the 1st of March we have substantial shoot growth, and this shoot growth is certainly vulnerable to frost damage. Thankfully, elderberries seem to be somewhat resistant to cold damage, and they seem to be able to compensate to some degree from damage from frost. But even so, it is a consideration for our farmers. Pollination issues related to excess rain. We have seen this several times in recent years. The flowering period for elderberry in Missouri is in June, and if we experience a great deal of cloudy, windy, wet weather during that period of time, it can actually interfere with pollination, and we see problems with the dropping of very small berries because of incomplete pollination or even the lack of fruit set. So this is an issue that we are concerned about. Certainly hail can be a devastating situation. Thankfully, hail is typically localized, it's not region-wide, but as this picture on the slide shows, hail can be devastating. It can certainly knock off flowers and fruit. It can knock off even shoots and leaves. Elderberries will recover following hail, as you can see in this picture, which was taken approximately 6 weeks after a hailstorm, devastating hailstorm, but oftentimes the crop is damaged substantially or even lost in that year. And then issues related to high temperatures, and we don't have a good handle on this, but we are concerned that high temperatures during flowering could perhaps lead to the abortion of the embryos in developing fruit, which could lead to a fruit drop and reduced crops. Now we're moving into the realm of elderberry management. In other words, the decisions that an elderberry farmer must make to ensure that productivity is at its maximum. In selecting a site for elderberries in Missouri, we have learned, first of all, that elderberries do best in full sun. Frequently, we can find wild plants growing in areas of partial or even deep shade, but from the standpoint of productivity, full sun is the recommendation in Missouri. We have seen issues related to high wind damage. One of our primary research sites in Missouri is on a very windy spot, and we have had damage to developing shoots and to the flower and fruit clusters from high winds. So a site that is protected from high winds will, over time, be a more productive site. And then a very important consideration is soil drainage. Now, elderberries do tend to be native to areas close to water, close to streams, lakes, and such. But in almost every setting, even though these plants are growing close to water, they're growing on soils that are well drained. And this has been our experience in Missouri as well. And in fact, making provisions for soil drainage can be an important part of long-term productivity in plantings. For example, as we'll see here in a moment, planting on raised beds or berms can be very helpful in prolonging the productive life of an elderberry planting. We have seen to this point that certainly cultivar selection, selecting an environment suitable for elderberries, and selecting a good site to produce the crop are critically important in managing for long-term productivity. Now we'll turn our attention to the active management of an elderberry planting and how that will impact productivity. We'll talk first about planting layout, then we'll discuss pruning, fertility management, and irrigation. We discussed earlier the importance of soil drainage for long-term elderberry productivity. This slide illustrates a bermed planting in Missouri, and many of our plantings are planted on raised beds or berms. The berm is typically between 1 to 1.5 meters in width and about 1/2 meter in height. The plants that grow on these berms tend to have better growth overall, and they tend to be more productive over time. Another issue related to productivity and planting layout has to do with plant spacing. And our farmers tend to space plants between 1 to 1.5 meters between plants. In this case, their goal is to develop a hedgerow or a solid row of elderberries. There are some growers who maintain American elderberry as individual plants, and in that case the plantings should likely be closer to 1.5 meters between plants to allow for management of individual plants. But the natural growth habit of American elderberry is to sucker from the root system. So in time, sucker management between plants can become an issue if the goal is to maintain individual plants. The Missouri elderberry crop is largely harvested by hand, and the labor that is needed to effectively harvest this crop is one of the most expensive inputs in producing elderberries in the Midwest. Farmers are interested in ways to improve harvest efficiency, and early in the course of the Missouri Elderberry Development Program, we conducted extensive research looking at pruning practices and their impacts on harvest efficiency. We learned that with many elderberry cultivars, the plants could be cut back to the ground annually, typically in late January. The plant response the following growing season would be to develop shoots from the crown. These shoots would be vigorous, upright growing. They would produce a single flower head at the top of the shoot. This would lead to a concentrated ripening period and the ability to harvest the majority of the crop in 2 to 3 harvests. This had, again, the impact of improving harvest efficiency, although in our research we demonstrated that there was a bit of a dip in yield using this approach versus a pruning approach where we maintain the plant as a woody shrub. We also have questions about whether or not this technique will work across the board with all American cultivars. It has worked reasonably well with the cultivars that we have investigated. And we also have concerns as to whether or not this system will work well in northern growing areas that have shorter growing seasons. We are encouraged not only with the improved efficiency of harvest with annual pruning to the ground, but also we see implications for eriophyte mite management. As we'll see here in a moment, these mites overwinter on the woody part of the shrub, and removing the woody part of the shrub removes the overwintering populations of eriophyte mites, and we've seen less problems with this pest in plantings that are pruned back to the ground annually. The other issue is related to spotted-winged Drosophila, and at the moment the primary management strategy for spotted-winged Drosophila, which we'll discuss here in a moment, is to spray the crop as harvest approaches, and anything that could concentrate the harvest and shorten the period of time to which the fruit is vulnerable to SWD will be a benefit to our farmers. Fertility management is a critical aspect of both short-term and long-term productivity in an elderberry planting. Obviously, when a plant such as the one illustrated in this slide is showing nutrient deficiency symptoms, productivity has been negatively impacted. This situation, though, can be present without visible symptoms. We call this hidden hunger, and certainly hidden hunger can negatively impact productivity as well. The management of nutrients, both macronutrients such as nitrogen, phosphorus, and potassium, secondary nutrients, particularly calcium and magnesium, and micronutrients all have an impact on productivity. Fertility management begins with a soil test during the site preparation process. It's very important at this point to make sure that the soil pH is in the suitable range for elderberry. Here in Missouri, we recommend a soil pH between 5.0 and 6.5. We also want adequate soil organic matter. That obviously has an impact on productivity. We would like to target 3 to 5%. And we also are very interested in phosphorus and potassium levels. The phosphorus level should be at least 80 kilograms per hectare, and the potassium level at least 150 kilograms per hectare. If these levels are not suitable in the soil in its native state, we recommend that they be modified before the elderberries are planted. The same consideration is for the soil pH. If the soil pH is too low, the addition of lime is indicated. If the soil pH is too high, then the addition of sulfur. Once the elderberry planting is established, then management of nutrients shifts over primarily to nitrogen management. Elderberries are heavy feeders for nitrogen, and our farmers are still gaining a handle on the adequate level of nitrogen to apply. We have just concluded a study looking at nitrogen rates on elderberry ranging from 0 kilograms per hectare up to 100 kilograms per hectare. And our initial results suggest that the suitable range for a mature bearing elderberry planting is at least 80 kilograms of nitrogen per hectare to maintain short-term and long-term productivity. We are also suggesting periodic soil testing during the life of the planting. Generally, a soil test about every 3 years will help diagnose problems on plants that are showing visible foliar symptoms and also help diagnose hidden hunger before it becomes a serious issue. To help again with looking at the efficiency or the effectiveness of a nutrient management system, we are now promoting foliar sampling, and we've recently conducted a study on the best time at which to sample elderberry foliage to get a handle on the success or failure of a nutrient management program. And it does vary with different types of nutrients. Certain nutrients are better sampled at flowering, while other nutrients are better sampled as the crop begins to ripen. Elderberries are not drought-tolerant plants, and having the access to irrigation is a critical aspect of maintaining planting productivity. Our farmers use drip or trickle irrigation systems. Typically, the system will include an 18 millimeter tube that has emitters that are molded into the line every 18 to 24 inches. These emitters typically emit somewhere between 1.5 to 2 gallons of water per hour. The water needs for an elderberry planting is somewhere between 38 to 50 millimeters of water per week. Here in Missouri, we expect droughts of varying lengths each summer, and so we do not recommend planting elderberries without provision for irrigation. Weed management is a critical aspect of maintaining productivity in an elderberry planting. Weeds rob elderberries of water, nutrients, and sunlight, and can also serve as hosts for elderberry diseases. Weed management begins before planting, is critically important when new plantings are under establishment, and becomes an important part of the ongoing management of mature elderberry plantings. It is very important to control perennial weeds before planting, weeds such as Johnson grass, Bermuda grass, and other persistent perennial weeds. A common practice in establishing young plantings is to use a temporary plastic mulch around the young plants or the cuttings as they are placed in the soil. This mulch is in place for the establishment year and is then removed. For mature elderberry plantings, frequently weed management has several aspects. Weed barrier fabric is becoming increasingly common in established elderberry plantings, particularly as a strip along both sides of a plant row. Mulching with organic materials such as sawdust or bark chips is also commonly done to maintain weeds along the edge of the elderberry row. In our experience, mulches should not be placed over the top of the plant, over the crown of the plant, as it can inhibit the emergence of new shoots in the spring. Hand removal of weeds, particularly perennial woody weeds, becomes an aspect of weed management in mature elderberry plantings. A number of herbicides are labeled for use on elderberry. Some of these herbicides are general herbicides and can easily damage elderberries as well, so they must be used cautiously and according to the label recommendations. Other herbicides are specific to grassy weeds and are safer to use on elderberry. This slide shows a newly established elderberry planting. Notice that the temporary plastic mulch is used in the center of the row around the newly stuck cuttings, and along the edges of the elderberry row, woven landscape fabric has been placed. The plastic will be removed as the young plants grow, and the woven fabric will become a permanent part of this elderberry planting. The area between the rows, the grassy area between the rows, is maintained by mowing. Now let's turn our attention to pest management and the implications that this has for productivity. There are a range of pest issues that can affect productivity on elderberries. With some of these issues, the effect is subtle and difficult to see, but there nonetheless. Other of these issues produce sudden and dramatic effects that can reduce cropping. So let's get a handle on what goes on from the standpoint of pest management on elderberries. In establishing an elderberry planting, it is always in the interest of the elderberry farmer to first of all eliminate wild elderberries growing in the vicinity of the managed planting. These wild plants can serve as a reservoir of pests that can then spread to the cultivated planting. Also very important whenever possible to start a planting with clean planting stock. At present in the United States, we do not have a good source of virus-tested elderberry planting stock, but we've been visiting about the need for this with a number of nurseries and hope that this situation will change in the future. It's important in established elderberry plantings to regularly scout the plantings. Some pest issues are expected every year. Other pest issues are sporadic and can arrive unannounced. And so a farmer must be on top of management with many pest issues. It's important to recognize the spectrum of management strategies. It's not all about just what do I spray, but there are other aspects to pest management on elderberries which we will touch on here in a moment. On the subject of pesticide use, there are pesticides that are currently labeled for elderberry in Missouri, both inorganic and organic options, but not nearly enough options are available to manage all of the pest issues that can become problems on elderberries. We are seeing an interest in developing additional labels for pesticides, so these tools will be available in the future, but at present there's only a limited spectrum of pesticides that are currently labeled for use on elderberry in Missouri. Aryphid mites are tiny, nearly microscopic pests that are found throughout the range where elderberries are native, and they are certainly an issue on elderberry production in Missouri. The mites feed on the new shoots as they emerge in May and early June. While they're feeding, they release substances, toxins, that cause the crinkling that is characteristic of the foliage. You can see it here in this slide. And if the infestation is high enough, their feeding can cause abortion of flowers and developing fruit. 2 species of mites have been identified in Missouri. Both species of mites overwinter on the buds near the tips of the woody shoots in the fall and through the winter and into the spring, and they begin their feeding very early, just as the bud shoots begin to develop. Management strategies for aryphid mites, which can be among the most damaging of the elderberry pests found in Missouri, include the removal of shoots during the wintertime, as we discussed previously with pruning practices. If these shoots are removed from the planting, the overwintering site for the mites is also removed, and we see lower levels of aryphid mite infestation in the elderberry orchards that are managed this way. The elimination of wild plants is also helpful, as these wild plants can be a starting point for infestations in cultivated plantings. There is some indication that the use of lime sulfur sprays early in the season, just as shoots begin to develop, may be helpful. Further research needs to be done to verify the effectiveness of these sprays. Spotted-winged Drosophila is a non-native invasive species of fruit fly that arrived in Missouri in 2013. This pest has seriously impacted productivity on elderberry in Missouri. This picture of a blackberry shows the larva of the spotted-winged Drosophila in the very center. The female spotted-winged Drosophila lays eggs on the elderberries as ripening approaches, and 1 or 2 larvae per berry can very quickly destroy the berry. The impact on productivity in some cases has been as high as 100%. It's a very serious issue for our farmers, and we're still gaining an understanding on how best to manage spotted-winged Drosophila. Some of the management strategies that are in place: planting should be monitored using traps that are baited with various mixtures of apple cider vinegar or fruit juices. This will help alert the farmer to the arrival of spotted-winged Drosophila. We are at a point now where we expect this pest every year, and unfortunately, in our trapping studies, the levels of spotted-winged Drosophila, the numbers of spotted-winged Drosophila, began to increase dramatically in July and August, just in time for the harvest of the elderberry. Other management strategies include removal of wild hosts near the planting. For us in Missouri, this includes wild elderberries, wild blackberries, bush honeysuckle, and wild grapes. We also remove herbaceous plants such as poke, all of which provide berries that can be used as host plants by spotted-winged Drosophila. The general management practice for spotted-winged Drosophila in Missouri is to apply pesticides to the berries as ripening approaches. This is unfortunately a challenge for our farmers, many of whom are growing these elderberries under organic protocols. With this approach, there is a limited spectrum of effective insecticides. Those farmers who are growing elderberries that are not organic have a broader range of pesticides from which to choose. But the fact that these pesticides must be applied frequently, generally every 7 days, and there must be a rotation among chemistries, different chemistries, to prevent the development of resistance in spotted-winged Drosophila, make even the use of pesticides a problematic approach to managing spotted-winged Drosophila. We are excited about developments such as the development of traps that selectively kill spotted-winged Drosophila. We're looking forward to future developments in this area. And our hope is that as time goes by, native pests or native predators and perhaps even parasites will take advantage of this abundant food supply and help reduce the numbers of spotted-winged Drosophila in our elderberry plantings. Japanese beetles are widespread across Missouri, and the feeding of the adults on the foliage, the blossoms, and the developing fruit can seriously impact productivity in elderberry plantings. The population numbers of Japanese beetle are sporadic from year to year. Some years there are incredible numbers of beetles, and other years very few. But again, we are at a point where we expect Japanese beetle infestation every year. Management strategies for Japanese beetle include the use of pesticides targeting the adults, and particularly in organic plantings, the use of mass trapping. This push-pull technique involves the placement of pheromone-baited traps around the perimeter of the elderberry planting. These traps are placed fairly close together, generally within 100 yards of each other, and they are baited with potent pheromones, which draw beetles out of the planting and intercept beetles as they fly into the planting. With this approach, management has been demonstrated in research studies of Japanese beetle. A number of insect pests are found sporadically on elderberry, but there are 3 that occur regularly enough that we consider them to be an influence on productivity. The first of these is the sawfly. The larvae feed voraciously on elderberry foliage. The adult is a type of wasp. Sawflies tend to be somewhat sporadic. We don't expect them every year, but when they are present, they tend to be present in large numbers. Management strategies: oftentimes the infestations are spotty, and in some cases can be dealt with by hand removal. In other cases, the use of a labeled pesticide can give adequate control of sawfly. The spindleworm is a borer that feeds internally in the young developing shoots of elderberry. Oftentimes the first evidence of spindleworm infestation is the collapse and death of the growing points. We don't expect spindleworm every year, and in many cases it's just scattered through the planting and we can tolerate the level of damage that is present. On occasion we have had hot spots or concentrations of spindleworm that have influenced productivity. In this case, management includes the removal of these tips as they wilt, oftentimes the larva is still inside, and the use of systemic insecticides which can then target the spindleworm larva within the shoot. Elder borer is a vibrantly colored large beetle. It's what's called a longhorn beetle or prionis beetle, and the larvae of the elder borer feed in the crown and the larger roots of the elderberry plant. We see these frequently in Missouri. We really don't know how much of a contributor they are to reduced productivity. In some cases, when we excavate large older plants, we do find evidence of elder borer feeding in the crown. But again, we don't know the level or the contribution of elder borer to reduce productivity. This is a pest that deserves further study here in Missouri. It is found widely across the state, and we do have some concerns, particularly in older plantings, that it may contribute to the gradual decline of older plantings. But again, further work needs to be done in investigating the contribution of elder borer to reduced productivity. Elderberry rust is a disease that has impacted productivity in several Missouri plantings. This disease has a complex life cycle. It requires 2 hosts, one of which is the American elderberry. The other is one of at least 12 species of sedges that are found widely in Missouri. Sedges typically grow in moist areas, and those plantings that are established near swamps, marshes, or bodies of water are more prone to issues related to elderberry rust. On the elderberry plant, the disease is expressed as these orange or yellow growths that may occur on the foliage, on the stems, or on the flower and fruiting clusters. A low level of infestation can be tolerated with no influence on productivity, but higher levels of elderberry rust should be managed. Management strategies include elimination of the alternate host, the sedge. This can be a challenge because sedges are widely found and once established in an elderberry planting can be difficult to eliminate. The other management strategy is to apply fungicides to the elderberry plants in late spring and early summer. This would be indicated in plantings that have a history of elderberry rust. Several other diseases have created problems from the standpoint of productivity. In many cases, these diseases are sporadic. They're certainly not statewide, but in an individual planting, they can be a problem. The slide illustrates a bacterial leaf spot that has been implicated in reduced productivity. There are also a number of diseases that cause problems with the death of shoots or canes that could be a problem. Again, these are generally scattered and oftentimes limited to specific plantings. Management strategies include proper site preparation, the development of open structures in the training system, pruning system that's used with the elderberries, the removal of wild elderberries in the vicinity of the cultivated elderberries, and in some cases the removal of the infested parts of the plant. This would be particularly the case with some of the shoot and cane diseases. We are increasingly concerned about the contribution of virus diseases to reduce productivity in Missouri. It's not unexpected that there would be viruses that are widely distributed throughout the plantings in Missouri. Most of the cultivars that we are growing have not been through a virus cleanup process, and in many cases these are elderberries that were developed from wild plants. So it wouldn't be unusual to expect viruses in the planting stock. Add to that the fact that elderberries are a widespread native crop. Oftentimes wild plants are found adjacent to cultivated plantings. It would not be unexpected that viruses could move from wild plants to cultivated plants. Some of the symptoms of virus diseases include unusual foliar symptoms, as we see in this slide here, but in some cases, virus infestation is not characterized by visible symptoms. The only thing that oftentimes indicates a virus issue would be reduced productivity. Management of elderberry virus issues is complex. It's important whenever possible to start plantings from new nursery stock, but unfortunately we have no clean plant program in place to develop parent plants that can be then used to propagate virus-tested stock. There is some interest in developing micropropagation techniques for elderberry. This would be a positive development, as oftentimes the process of micropropagation includes the management of viruses found within the explants that are used to create additional plants. So we are encouraging nurseries to do this, but at present we do not have a good source of virus-tested planting stock. It's very important that if a farmer is propagating their own elderberry plants, which is commonly done in Missouri, that the stock plants chosen be free from visible symptoms of virus infestation. We also have a project underway to help characterize the different types of viruses found in elderberry in Missouri. So based with that knowledge, hopefully we can help develop interest in the nursery industry in developing a clean plant process and encourage the availability of virus-tested planting stock. A final pest issue of concern to Missouri elderberry farmers is bird depredation. And a number of bird species will feed upon elderberry. It's a widespread issue. Typically it's more noticeable in smaller scale plantings, as would be expected, but even large plantings can report damage from birds. One of the interesting aspects of elderberry growth as it relates to bird management is the orientation of the fruit clusters at harvest. We've learned from experience that clusters that are in a decumbent position, as we see in the lower slide, are less attractive to birds than the flower or the fruit clusters on plants that are held in an upright position, as you see in the upper slide. Birds seem to be less comfortable feeding on the decumbent berries. The lower picture is Bob Gordon. The upper picture is wildwood. So again, another determinant that is helping farmers favor Bob Gordon over wildwood in Missouri plantings. Bird management includes scare tactics, things such as scare eye balloons, cracker shells, the use of avian distress calls over loudspeakers, or other reflective type materials. In some cases, netting is placed on elderberry plantings as ripening approaches, but this is an uncommon practice in Missouri. Harvest management is a critical component of productivity. The farmer must be prepared to make a number of decisions at this point that directly impact productivity. Decisions related to harvest timing, harvest management, de-stemming, and post-harvest handling, if made well, can lead to maximum productivity. If there are problems with these decisions, there is no recovery. Determining when to harvest elderberries. On the surface, this looks like an easy decision, but it is actually much more complex and has serious implications on productivity. In the past, much of the Missouri elderberry harvest was intended for use for jelly, jam, or wine, and in these cases, we could base harvest primarily on berry color. As the industry related to health supplements has developed, it's become increasingly apparent that it is desirable to have consistency in the processed product. And in order to have consistency in the processed product, both from the standpoint of things such as bioactive compounds, but also colors and naturally occurring sugars, it's very important that the crop be harvested at a point of consistency. And so we're increasingly seeing the determination for harvest based not just on berry color, but also increasingly on juice chemistry. If we look at these two pictures here, we see two elderberry clusters where the majority of the berries are dark. The lower cluster, all the berries are dark, and typically as we have run juice chemistry tests, and we've done thousands of these over the years, we see a much more consistent level of juice pH, juice sugar content, the acidity levels in that juice, and the levels of bioactive compounds compared to a cluster as we see in the above where there is a scattering of red and green berries. So it's very important, yes, that we look at berry color, but we are now starting to recommend that farmers test the berries for these juice components to make sure that we're delivering a product that is consistent for the intended use. Harvest decisions are also based upon the condition of the crop. We have made a strong effort in the past to only select elderberry cultivars that hold their berries well. There's nothing more frustrating to a farmer to have done everything right, and then as harvest approaches to see the berries shatter and be lost. The berries are small. There is no recovery from shattered berries. And this is a problem certainly before harvest, but berries that tend to shatter and fall off the cluster can be a serious issue at harvest. Proper harvest practices are a very important part of capturing the productivity that is potential in a crop. Again, nothing is more frustrating to a farmer to have done everything right, to see the potential for productivity in a planting, and then to lose it during the harvest process. Elderberry should be harvested early in the day. At this point, the berries are fully turgid, and you have the maximum quantity of fruit in terms of mass present on the plants. The entire cluster should be carefully clipped. It should then be carefully transported to the harvest container and set gently into the container. Again, even clusters that are dropped a short distance, a half a meter for example, we can see shattering and loss of berries outside of the harvest container. So it's very important that pickers be trained in the proper harvest practices. The harvested berries should be transported quickly to the destemmer. Whenever possible, berries should be destemmed immediately. If immediate destemming is not possible, then the berries should be cooled. Again, even a short delay in cooling or destemming can lead to the loss of moisture from the berries and to reduced yield. Berries may be destemmed either fresh or frozen. If fresh berries are to be destemmed, they should be destemmed as soon as possible after harvest, while the berries are still fresh and fully turgid. A fully turgid berry will separate much more easily from its pedicel. There'll be less tearing and loss of juice. If the berries are to be destemmed frozen, the fruit clusters should be frozen as soon as possible after harvest. Once frozen, the window in which destemming can occur is wider, but again, more productivity, better capture of the berries and the juice is done if the frozen berries are destemmed fairly soon after harvest. This particular slide shows a destemmer that is a modified grape destemmer with fairly small holes in the cylinder that can be then used to destem either fresh or frozen elderberries. This slide shows another type of destemmer. In this case, two screens move in opposite directions to each other, and the berries are sheared from their stems by the action of these screens. This video will demonstrate the destemming process using the type of destemmer that we just saw with the screens moving in opposite directions. Notice that the clusters come in, they're placed on the machine, the shearing action of the screen separates the berries, and then at the very end we see clean flower clusters. And this again is an important aspect of productivity, to capture as many of the berries as possible during the destemming process. The yields listed on this slide are the result of many years of cultivar trials. We generally expect a substantial yield in the first year, somewhere between 1,200 to 1,300 kilograms per hectare. We expect that yield to double in the second year of production and to double again in the third year of production. Elderberries are generally in full production by year 4, and our farmers expect yields between 6,000 to 7,000 kilograms per hectare. Our high yields in cultivar trials have exceeded 12,000 kilograms per hectare. In conclusion, let's revisit the main points of my presentation. First of all, we discussed what productivity is, and we've realized that productivity is actually an intersection of the genetics of the elderberry plant, the environment in which it is grown, and the experience of the grower who's producing the crop. We also have to remember that productivity is not the only aspect of profitability. Efficiency is just as important, and sometimes more so. It's very important from the beginning to design a planting with productivity in mind. It's also very important to choose cultivars carefully. In fact, probably the most important decision that an elderberry grower can make in establishing a planting is choosing cultivars carefully. We must remember that all aspects of management have an impact on productivity, from the selection of the site, the development of the planting, the management of the planting, and the management of harvest and post-harvest handling. Remember that pest management has a direct impact on productivity. Pest issues may be subtle and unnoticed, but still impactful, or they may be sudden and dramatic. But nonetheless, pests must be managed to maintain productivity. And finally, everything can be done right, but if we don't manage harvest properly, both harvesting berries, managing harvest labor, doing a good job of destemming, and then properly managing the berries post-harvest, we can see a loss of productivity at this point. So again, productivity is a fairly complex situation, but if we understand the underlying aspects of productivity, it is definitely a goal that we can achieve with elderberry production. Thank you very much. It's been a pleasure to be with you here today and to discuss the experiences of Missouri farmers related to elderberry productivity. Please feel free to reach out and contact me if I can be of assistance. We also have a number of elderberry resources at the website address that is listed here on the slide. I think at this point we have time for some questions, so I'll look forward to fielding any questions that you might have. And again, thank you for the invitation to be with you here today.